All right, good evening. So it's going to do a little weather briefing here. I will apologize in advance. I'm a little bit sniffly. I caught the AMS plague, the light version, I should say. Wasn't too bad, but yeah, just going to talk a little bit about what's going on, what to expect in the next few days here, mainly across central Oklahoma. I know there's a big storm out in the Northeast that everyone's going crazy over, especially on Twitter, but I'm going to try and focus on our neck of the woods here in central Oklahoma. So this is mid-level water vapor imagery. And as you can see here, really the eastern two-thirds of the country looks pretty quiet, with the exception of there are some snow showers over parts of Nebraska and South Dakota. Granted, this is in the mid-level, so we can't see what's going on at the surface, but you do see some cloud formation associated with that. Also, this main system of interest, and this will be what we're concerned about here in Oklahoma into the weekend, is this really large extratropical cyclone pushing into parts of California and Oregon, and that's bringing them some heavy rain as well as some embedded thunderstorms. So this is really going to be the feature of interest that we're going to have to pay attention to in the next few days. So this is GOES 17. I believe this is visible in an IR composite. You can see this really nice extratropical cyclone, that nice comma head feature associated with that, and that cold front dragging south, as well as that cold top convection behind that, very shallow convection, but really cold cloud tops, as well as some moisture that's kind of wrapping around the center of circulation. And if you actually pull up, this is isentropic analysis. If you go back to the northwestern U.S., just analysis, you can actually see that. So where the wind barbs are pointing from areas of higher pressure, so closer to the surface down here over Oregon, to areas of lower pressure or higher up in the atmosphere, that is what we associate with ascent or isentropic ascent, and also warm advection. So it's really not a surprise we're seeing all those clouds up here in this portion of the cyclone. Let's see. So yeah, just going back to let's go to Oklahoma. Just to kind of talk a little bit about the fog that we saw today. So we've really busted on our high temperatures today. We were really unable to mix out that low level moisture. And part of the reason that is we also are seeing some of that isentropic ascent, warm advection and moisture advection across really central Oklahoma. So that really brought in some moisture. It also brought in some slightly warmer air than we've seen in the past few days, but really kept that stubborn stratus deck around, and we didn't really see much sunshine today. Hopefully that'll change tomorrow. But tonight, kind of expected to stick around, especially as we continue to add in that moisture. And pulling up a sounding actually from this evening, it makes sense. We see that low-level saturated layer, really shallow. We're saturated at the surface. Also fairly weak winds at the surface. So that really limits the amount of mechanical mixing that we see. And really not many clouds above this little shallow moist layer as well. So we're really going to effectively cool from a radiative perspective. Also that veering wind profile, especially in the lowest levels, so that implies warm advection, which is similar to what we saw in the last chart. And just kind of a similar, an interesting feature is the steep mid-level lapse rates extending from roughly 850 millibars to 700 millibars. Not really certain we're going to see a lot of convection with this upcoming system into the weekend, but it certainly would be nice. But I won't complain. We've actually received quite a bit of rain, especially for January standards. It's been very wet, tremendously wet, tremendous amounts of water here in Oklahoma throughout the month of January. This is just the current radar picture. We talked about those snow showers mainly across Nebraska and South Dakota. Maybe a few minor travel issues across I-80 and I-70, but really the main story is those heavier showers and thunderstorms across Northern California, where they are receiving quite a bit of rain, as well as up into Oregon and Washington. But overall, fairly quiet across the eastern two-thirds of the country. This is the Oakland sounding. This is from this evening. You can see just a deep, moist profile there. They're right in the thick of all that rain, even a few thunderstorms. Moist adiabatic up to almost 200 millibars. 1.1 inches of precipitable water, so I'd imagine that's well above their mean climatological value. Also a little bit of CAPE below 500 millibars, so there is some instability. So it's really not a surprise that we're seeing some of those thunderstorms there. Also strong warm advection with that low-level veering wind profile. These are just surface observations across the central and southern Great Plains. Little weak cold front across northwestern Oklahoma. Not even too much of a temperature gradient. Mainly behind it is where the larger temperature gradient exists. So we would also expect for there to be some sort of jet response aloft. I'm not going to nerd out about thermal wind balance and all that, but Anyways, just fairly weak southerly flow across the southern half of Oklahoma. Some widespread fog as well as some freezing fog, mainly along the I-70 corridor as well as north of I-70 into Nebraska, and also some light snow showers across parts of central and northern Nebraska. But overall, fairly quiet conditions this evening. This is just the 500 millibar height pattern. This is the 500 millibar height pattern. That was E50 advection. So I'll show that in just a bit. But really, there's just that weak shortwave trough that's managing to helping to initiate a few snow showers across the central Great Plains. But really, the main feature of interest is this deeper shortwave trough that's about to impact. That's just about to move onshore and is already impacting parts of California and Oregon. Back to the 850 millibar thermal advection right here. The red is warm advection. You can see that's particularly over much of Oklahoma. So it's really not a surprise that we're seeing quite a bit of fog and stratus associated with that warm advection and that isentropic ascent. Typical to see that, especially in the colder months when we see a lot of that low-level moisture pushing in. So moving forward, let's go back to Friday. So again, I'm not terribly enthusiastic about precipitation chances here in Norman, especially, or I should say snowfall chances here in Norman. It looks like this is going to be a fairly progressive system. It's going to be moving fairly quickly, and it looks like the majority of the actual ascent is going to be well before the colder air actually gets there. And I'll show you that here. So this is 12Z Friday, so this is early Friday morning, and you see there's that isentropic ascent. There's those winds pointing from areas of higher pressure to areas of lower pressure over central Oklahoma. And that persists a little bit through Friday, even a little bit through into Saturday, early Saturday morning. But so this is 6Z, so this is midnight on Saturday. But then we start to lose that as we head into Saturday morning. But if we look at 6Z Saturday, so this is really the end of when we're expecting to see most of the ascent. This is just one model, so the timing can vary between models, and it can change up until the timing of the event. But I'm just going to pick a sounding for Norman. We're just going to plot a sounding. And as you can see here, surface temperatures are still fairly warm. You can see the front has already moved through. Winds are out of the northwest of the surface, but a 45-degree surface temperature. Fairly moist aloft, but really doesn't look like the bulk of the cold air is going to get here in time. So it doesn't look like the lift and the colder air are really going to be in sync, giving us much of a snowfall potential. But this can also change. We will keep an eye on this in the coming days. This is the 500 millibar geopotential height pattern, as well as the geopotential height anomalies. So there's that shortwave ridge that's going to build in really tomorrow into Friday. So that'll probably bump up our temperatures a little bit tomorrow into Friday. But ahead of this next shortwave trough, we can see it does deepen quite a bit, but it really is very progressive. So this is really not a prolonged snow event that we're going to see if we do even see some, even if we do see any snow, that is. Which I'm not really expecting here in Norman. Maybe a little bit, but it really depends on the timing of when the cold air gets here and how that relates to when the precipitation is here. This is the 850 millibar thermal advection, so this can really tell us about the ascent that's ongoing. This is at least one of the terms, one of the ways we can diagnose areas of ascent. This is Friday, and you can see the warm advection mainly across Kansas as well as extreme northern Oklahoma. So I don't know, let's cherry pick a sounding across northern Kansas. So this is something that we would see, we'd expect to see a freezing rain sounding out of. You see that warm nose, that warmer area extending above the 0 degree isotherm, but at the surface we're at 32 degrees Fahrenheit. So any precipitation that manages to fall will freeze on contact at the surface, especially elevated surfaces. So maybe a more significant event there. If we can plot a cross section, we can do that here. This is the great thing about tropical pigments. This is frontogenesis and ascent. You can see there's some ascent, but it's mainly below this zone of what we call the dendritic growth zone. This is the minus 12 to minus 18 degree layer. It's where we got a lot of our dendrite formation. So it's mainly below that. Also some low-level frontogenesis, but really not much in the way of heavy snowfall event, at least from what this model is showing. This is the GFS. Granted, this is the 18Z run, so I would like to look at the 0Z run. I'd put more faith in that, but we'll go off this for now. And lastly, this is potential vorticity, and you can see really just this is to give an idea of how cold the air is going to be behind the front. This might be associated with what we call, so we see lower tropopause heights here moving across central Oklahoma. So that generally corresponds to much lower temperatures at the surface. And if we pull up the 2 meter temperature anomalies, you can see just ridiculously cool temperatures starting to push their way um, across the central and southern Great Plains, almost 10 degrees below normal. So it's not as chilly as models have been trending in the past few days, but we will definitely be below average in terms of high temperatures, and really the cold air looks to be bottled up north. Again, this can change in the next few days, but it'll be interesting to see how this all pans out. So yeah, thank you for watching this. Hopefully that provided at least some sort of insight into what we're going to see into this weekend, and enjoy the snow if we do manage to get any.